The acquisition of big data is controlled and managed by 4 V's. What is the importance of these characteristics in the big data? The first and the foremost characteristic is the volume. So velocity is nothing but speed of generation of the data. Hello students, welcome to the next session of Cloud Computing and Big Data Analytics. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram College. Let's start with this session with the big data characteristics. What we need to know is the characteristics of the big data. Okay. In the last session, I was discussing about the big data definition. What is big data? How you can acquire the big data? What are the things you need to acquire the big data? And the types of data. What types of data in big data we have is the structured, unstructured and the semi-structured type of data. Is it not? Let's move on to the big data acquisition. In big data acquisition, I told you one thing. The acquisition of big data is controlled and managed by 4 V's. We have the 4 V's, that is the volume, variety, velocity and the variability. Let's check each of these. What is the importance of these characteristics in the big data? All right. The first and the foremost characteristic is the volume. The volume of the big data. Okay. The big data name itself is related to the size, isn't it? Big in size, larger volume or huge volume, isn't it? Which is meaning has the enormous or big. Simply it can say is big data. It is big in size. Size of the data plays a crucial role in determining the value of the data, determining or analyzing the data which are acquired as big data. Okay, whether a particular data can actually be considered as big data or not, or when you have acquired a certain size or data, first thing what we need to do is checking the size of the data. How much the memory space the data is going to occupy. Whether the memory size the data is going to occupy can make it or can take it to the category of big data, or can it be categorized as normal data. That is where the volume has to play a vital role, because the volume is the main key in big data, isn't it? If you don't consider the volume, you cannot categorize properly whether it is a normal data or a big data. Is it not? It is depend upon the volume of data, the decision of categorizing the acquired data as normal data or as big data mainly or solely depends on only the volume of the data. The volume is therefore the volume is the main characteristics which need to be considered while dealing with the big data acquisition. Mainly deals with gathering the data. While you gather the data, you have to make sure that you are gathering only the big data, not the smaller data. That data which occupies only few gigabytes. That must be around terabytes. How do you define? Is left to the applications and those who are storing the data. They have to decide how many size or which kind of data they will be considering as the big data. All right. The next characteristic in big data is the variety. Okay. The variety is the next aspect that must be considered for the big data acquiring. Okay. Variety is referring to heterogeneous form of data, isn't it? And sources of the data. From how many sources? From heterogeneous sources, you have to acquire the data. From not only a single source, the data or the source of the data must be heterogeneous. Data will be heterogeneous. Along with that, the source of the data from where we are acquiring the data must also be heterogeneous. Both may be structured and unstructured. You need to have heterogeneous source of the data. In the earlier days, the spreadsheets and databases that we use, Excel as well as the database, the DBMS applications, were the only source of the data. From where you can get the data or where you are going to store the data is either in Excel or in RDBMS or in DBMS. Okay? The data considered by most of the applications, only 2 applications were there, or the source of data were there where you can store and process the data. But nowadays, data is in the form of emails. It may be in the form of emails or photos or videos or maybe monitoring services, capturing the video in a closed circuit camera. It is also a kind of data which cannot be stored in the normal DBMS or in Excel sheet or spreadsheet, isn't it? Or you may have the PDFs or audio. In audio also we have so many different formats, isn't it? You can have the combination of all these or few of these in your acquired data are also being considered as the data and is considered for analyzing it. Based on the analyzation, certain output will be drawn. As I said, video, if you have a video, you can analyze it. If you have a video of a closed circuit camera, you have to analyze what kind of attacks are being done and how you have to store the data for processing. Okay? And you are going to get the data. Like in election time, what we are going to do, we are going to keep a closed circuit camera which captures the process of the election. Not voting will be confidential, but entire process of voting will be recorded in closed circuit camera. The exit polls will use these things to process the exit poll or process the result before actually the counting of the votes are going to happen. This is a variety of data that we are going to be handling in the recent days and even in the future. Okay? In the past, we didn't have that much variety of data. Only structured type of data were there and were easy to handle by the normal database applications or spreadsheets. They used to handle the data. But with this much variety of data, the spreadsheet, neither the spreadsheet nor the database can handle this much variety of data. So we need a special application which can store as well as process these data. All right. This variety of unstructured data that I am listing here is all are unstructured data that may get you into certain issues for storage. How to store these data? The first and the foremost doubt we get is, if you get a new variety of data, where I can store, in which category of data I have to store this. So that is the issue that happens or that arrives or that will be faced by the controller or the manager of the data. Not only storing, the next thing what we have to do is, we have to mine the data. Data mining depends on the big data. It usually doesn't depends on normal data. Even you can do the data mining with the normal data. But the real application of data mining is with the big data that is stored. Okay, you have to store it, mine it, and once you get the data from mining it, you have to analyze. You need to have the algorithms for analyzing all these data, which are normally unstructured in the format. You have to do all these things with the variety. So variety also plays a vital role in analyzing, storing, analyzing, as well as getting the analysis of the data, storing, mining, as well as analyzing the data. The next characteristic that we are going to know is of velocity. Suddenly we switch to science, physics, like velocity. What is velocity? In normal term, velocity is nothing but speed. Okay, so velocity refers to the speed of the generation, the speed in which the data is generated. Okay, generation of the data in which velocity the data is being generated in the IT world. So velocity is nothing but speed of generation of the data. How fast the data is generated and processed. You need quick result. Today, in nowadays, we need quick result. We can't wait for half an hour. We can't wait for 1 hour to get a result. We need immediate result. Within few minutes, I'll give you the data. Within few minutes, you have to process and give me the output. So that is what the main thing. Today, speed is running everything. Speed is the main thing that accelerates everyone. We need to be speed. We need to be ahead in the race. That is the velocity or the speed, which tells you how fast the data is generated and processed to meet the demands, determines the real potential in the data acquisition. Storing, acquiring, processing with your own speed will not work today. You have to be as speed as possible to meet the varying demands of the customers of the big data. You will have customers for your big data. That means you need to fulfill the demand with utmost speed. Okay? Big data velocity deals with the speed at which data flows in from sources like business process. There will be one of the source of data, business process. You have an organization, the data will pour from organization towards the big data application. Application logs, you'll be having various applications related to the particular business. Suppose if you have shopping, or if you have certain applications, gaming applications, you will get the application logs, application database which stores the data. Along with the networks, data will pour from the network, and social media sites, even they are the main source of the data today, social medias. Okay? Or maybe from sensors, sensor nodes, mobile devices, all those are the source of the data from which the data is going to be directed towards the server or the big data application. Okay? The flow of data is massive. It is not small. It is massive. Along with massive, it is continuous. There is no break for the transferring of the data, for acquisition of the data. Each and every second of the time will be utilized to store some data, to process some data, as well as to analyze some data. each and every second and or microsecond or nanosecond is going to be used by the big data applications to store the data and process it, because we are going to get the data at every second. If I am monitoring a big data application, you can observe that every second you get terabytes of data coming towards your application. Okay, that is where the velocity is also important due to the competition in today's world. The last V or the last characteristic of the big data is variability. The term variability refers to the inconsistency. That is, data will be varying, maybe in size or type of data. The data will be varying, which can be shown by the data at times. Each time when you acquire a data, you will get inconsistent data. They are not in same format. Each time you get a data, they may be in different format. This minute, I am getting a video file. The next moment, I may get a text file. In the same moment, I may get another audio file. Or maybe same time, I may get poured with all these heterogeneous types of data. That means there is a variability or inconsistency in getting the data, which hampers or which affects the process of handling the data and processing and analyzing the data. If there is no consistency in form of data that we are receiving, we find it extremely difficult to analyze it or to process it. First of all, you have to process it. There is no consistency in form of data that I am receiving. I have to process a data or a big data, but what problem I am facing is, every minute I am getting heterogeneous type of data, different variety of data. There is no consistency I can expect from any kind of data, which makes the task of processing and analyzing it a difficult task. Okay, these are the 4 V's or 4 characteristics that going to perform a vital role or an important role in the processing and analyzing of the big data. All right. With this, let's move on to the next thing, that is, where does you can find the application of the big data, where you can apply the big data application. The first is the smart grid case. The first application is the smart grid case. It is crucial to manage the electric power consumption and monitor the smart grid operation. We have electric grids, isn't it? So each minute or each second, you'll be having different voltage of electricity coming to the grid. You have to have uniform voltage when it gets out of the grid to the individual power supply. You cannot have the varying or fluctuation in the voltage. The grid gets varying voltage of power from the power source. When you get it, you cannot let the power source as it is with varying voltage. What you have to do? You have to manage the voltage, and uniform voltage must be provided to the individual power stations or power sources which provide the power to the individual house or shops or individual elements. So that is, the smart grid case uses the big data. How it is going to use the big data? It is achieved through multiple connection among smart meters. We will be using smart meters, sensors. You will be using the sensors, control centers. You will be having various control centers and other infrastructures which help in managing the grid power. Okay, we have the national electric power consumption. You have to manage the consumption of the power. Each and every second there will be so much of voltage of power, electricity that are being used by the individual elements. It will be very much less or negligible in case of a home. If you are in a home uses negligible amount of electricity. The most of the electricities are used by industries, the malls and all those big investment or big organizations are going to use the most of the power. Okay. Now what we need to do is the big data is going to get the power consumption, and the operations of the smart grid are also maintained by the big data applications, like using the smart meters, sensors, control centers and miscellaneous infrastructure that support in these tasks. Okay. The big data analytics, that is, analytics is nothing but analysis of the data. Okay. The big data analytics helps to identify the at-risk transformers. The list will be there of transformers, how much power is going out from each of the transformers. If there is any problem that is arising or risk that can happen in a transform, and to detect the abnormal behavior of the connected devices. So the transformers are connected with various devices. If there is any risk, because every second power will come from the grid to the transformers, the big data application has to monitor, has to collect the power that is coming to each of the transformers in the area or in the entire country or in the entire state. If it is state, you have to check with each and every minute of power that is being transformed or that is being transferred to the transformers. And you have to check if there is any possibility of risk in any of the transformers and the connected devices. Next, what you can do, you are analyzing, just not getting the collection of the data, that is power that is coming to the transformers. Along with that, you are analyzing this data for risk, possible risk that can happen in the transformers. Along with that, the grid utilities choose the best treatment of action. The analysis of data or analytical algorithms will help the individual to assess the chances of or probability of risk and can take the proactive action to avoid such risk. Okay. The real-time analysis of generated big data, because in a state we will be having lakhs of transformers, not only 1,000, you will be having lakhs of transformers which generate enormous amount of data. Every transformers, every second's power consumption or power acceptance must be monitored, must be acquired and monitored. Okay. Generated big data allows to model the incident scenarios, the possible scenarios that can happen in each of the transformers. Along with that, the advantage of using big data application is enables to establish the preventive plans, strategy to prevent the risk in order to decrease the corrective cost. Preventive cost is always less than detective and corrective cost. So prevention will not only reduce the risk, reduce the possible damages that can happen to the resource as well as maybe to the human beings or living things. It can reduce the cost of detecting it and correcting it. Preventive cost will always be less than all these action taking after the incident happens. If you avoid this, it will be better, isn't it? It will decrease the corrective cost of any mishaps that can happen in the grid, isn't it? Along with that, energy forecasting analytics. How much energy is consumed by each of the transformer? What is the role of analyzing the energy consumption is, if there is any error or if there is any problem in any of the machine in the transformer, it may use or it may consume more electricity. By analyzing the energy that is being consumed by a transformer, helps to better manage power demand load. If you find that a transformer in a particular area is consuming more electricity or passing more electricity, you can assume that there may be a fault in one of the component that has been used in the transformer. So you can send a person to check it and correct it, which reduces the power supply or power consumption by those transformers, and you can utilize the resources better with the analysis of the big data in a power grid. All right. The next application is in health. We have the application as e-health or electronic health. It is connected with health platforms that are already used to personalize the health services. So we are using big data to analyze and personalize and store and analyze the health related data. Okay, in this, big data is generated from the heterogeneous sources. What are the heterogeneous sources here is laboratory and clinical data. Various tests will be done when you go to the hospital, blood test or urine test or any kind of data. That will be the clinical and the laboratory data. Patients' symptoms can be stored, uploaded from the distant sensors. If you are having an online interaction with the patient, hospitals, operations, operation details, pharmaceutical data and scanning reports. We have various scanning that has been done over the entire body. Those scanning reports are different from other clinical data that comes to that of a particular patient. If you have a patient, if he undergoes various tests, scanning procedures, he'll be having the big data will get, or the data acquisition will have heterogeneous sources, because scanning report is different, X-ray report is different, test report format is different, the symptoms list is different, the medications that are suggested by a doctor is also having a different format. So you'll be having the heterogeneous source of data in case of e-health. What you can do? The advanced analysis of medical data sets, you can analyze the medical data sets, has various beneficial applications. What are the various applications you can have, or benefits of having a e-health for big data used in big data application used in health field is, it enables to personalize the health service. You can store and analyze the data of particular patient, isn't it? So if you have hundreds of branches of an hospital over the state or over the country, you can store the data of each of the individual for lifelong time. If he has started his service in that hospital, or he started his getting treatment from earlier age till his death, there will be so many treatments he has undergone in those 40 to 50 years of duration, or say 40 years of duration. Now, what you have to do is you have to store all those history of his medications, symptoms, everything, isn't it? When he comes next time for a treatment, you must get all the history of the patient, what are all the treatments he has taken, what was the symptom, what are the allergic conditions the patient have, all those details will be considered as the big data. The analysis of this medical data will help to personalize the health services. Like doctors can monitor the patients online with certain clear symptoms in order to adjust the prescription. If some patient is there who is remotely connecting to the doctor through online application or through phone or maybe through laptop or mobile, the doctor can check the history of the patient, what are all medications he got, what was the body condition in the previous treatment, what are the allergies, possible allergies the patient can have. All these things can be acquired by the doctor with the touch of a button or with the touch of a key in your keyboard, in the keyboard. So this helps in online service given by the doctor. Okay. To adopt public health plans according to population symptoms. What are the health plans? Like the polio vaccines. So you can get the polio vaccines by analyzing the data that has been given by the hospitals. So government will analyze in this period of time, in this year, say 2020, how many children have got the, or how many hospitals have got how many cases of polio. So using the records, patient records, the government can plan or can analyze or generate the health plan according to the symptoms that are going to be generated for a child, isn't it? Disease evolution, evaluating the disease and the related parameters. Like we have the pandemic, if the vaccine is there, so how much vaccine must be given, what are the allergies of the patient, what is the environmental effect on the vaccine that can be given. All these parameters can be considered by taking the e-health using big data application for health records. Okay. It is also useful to optimize the hospital operations. Hospital not only have the patients and the doctors, it also includes the nurses, the persons who handles the clinics, the scanning centers, pharmaceutical guy, those who are sweeping, cleaning, the persons who are operating in the operation theaters will be having supporting system along with doctor and patient. Even though health facility mainly has two persons, doctor and the patient, we need supporting system to make the health facility more strong, isn't it? So the big data also helps in operating the hospital, entire hospital, and helps in reducing the cost of operation. Operation is nothing but processing of or managing the entire hospital. So managing cost will also be reduced with the help of the e-health or with the help of big data application applied in the health field. Alright. The next field where you can apply the big data is the Internet of Things. So you know about the field of Internet of Things or IoT. The IoT represents one of the main market of the big data applications. You know about the Internet of Things, isn't it? Example of getting FASTag for the vehicles or accessing the barcode in the malls. That is, while you shop, you will get the barcode. When you scan the barcode, the data details will be stored. You will get lights on when you enter to the house. So these are the few of examples of Internet of Things. That is, network can be used for all these things. Internet of Things, you have Alexa that can listen to your word. You have the kiosks. So these are the Internet of Things that helps the network apply to the normal things of the life, which is called as the Internet of Things. Alright, because of high variety of objects, the applications of IoT are continuously evolving. So nowadays, there are various big data applications which support for logistic enterprises, like what kind of goods you are taking, how much goods you are taking, no need of counting it each time. When you scan only the barcode that is given to a commodity, you can easily scan from where it has come, where it is going, which are the intermediate stops that are being used. All those details will be acquired with the help of the big data applications. It is possible to track vehicle position with sensors. You will be having sensor for the vehicle. So there will be a tracking of the vehicles using the GPS. You can track the position of the vehicle. Where is the vehicle? With sensors, wireless adapters and GPS. With the help of few of components, you can get the track of a vehicle. Where does the vehicle is going? Where does the vehicle is, from where does the vehicle is coming? All these details can be tracked in the Internet of Things. Alright. So such data-driven applications enable companies not only to supervise, it will allow the company not only to supervise and manage the employees, along with they can optimize the delivery routes. Suppose if a vehicle is getting repaired, if the tire gets flat in the middle of the road, by tracking the vehicle position, the person sitting in the office can make an arrangement to get the vehicle repaired, and the vehicle can move smoothly in its path. Or else with the help of the GPS, if there is any disaster happening in a particular area, suppose the truck is going in a hill station and there is a landslide in that area, the person sitting in the office can get the information of that disaster and can notify the truck driver that there is a problem that can happen in the path that you are going. Change the route that you are going. You cannot go in that route where you are going. So change the route. He can notify the truck driver that he can change the route with the help of the GPS and the tracking of the vehicle position. Okay. So he can optimize the delivery routes. He can know in which route the fastest the delivery can be done, or the truck can move fast without any break. Alright. This is by exploiting and combining various information. How we can do this is by exploiting and combining various information which includes the past driving experience. How does the experience of the driver, how best he can drive in the hill stations, the tricky routes, how he can get. From where he can get the details is from the transport departments. He'll be having his driving license. The driving license details will be stored in the server of the transportation department, where when you get into the details, the license ID of the person, the track record of the driver can be taken, because you can check, the manager can check with whether the driver is a safe driver, he has done how many accidents, what was the experience of the customers, if he is you have the public transport vehicles, isn't it, like Ola and Uber. So while selecting the driver in a company, the owner or the manager of the company can ensure the past driving experience of a driver by getting into the history of the accidents that the person has done in the previous driving. Okay. Along with that, smart city is also a main area based on the application of IoT. So you can create a smart city with the help of the IoT applications. The next application of big data is in public utilities. In public utilities such as water supply organizations or some other service providing like the municipalities, the corporations can get the sensors in the pipelines. If it is water supply, the sensors will be provided or sensors will be applied in the pipelines to monitor the flow of water in the complex water supply network. If there is any damage to the pipeline in some intermediate place, by getting into the accessing of the sensors or data that are collected from the sensors, the water supply department can get into the flow of the water, where is the leakage of the water, in which area the leakage is happening, and they can make the repair of the pipeline in that particular place. Along with that, the example here is the Bangalore Water Supply and Sewage Board. What it has done is implementing a real-time monitoring system using the sensors to detect the leakages, water leakages, illegal connections. You will be having illegal connections who will not pay for the water used, to collect the details of the illegal connections and remotely controlling the valves. So there will be a valve which opens and closes. Previously or in the past or currently, we have the persons to open the valve and close the valve. With the use of the big data application, all these things can be automated to ensure the supply of water, sufficient water to the city. So it reduces the work and increases the efficiency of the department. It also helps to reduce the need for value operators and to identify and fix the water pipes that are broken or that are leaking. Okay. These are the some of the applications. Apart from that, we have few more applications. The area to which the big data application can be applied is enormous. You cannot imagine. But these are the few of the applications you can get into where it uses the big data application efficiently. Thank you.